So today's speaker is Steve Wilson. Steve is a groundwater hydrologist with the Illinois State Water Survey. We're really excited to have you with us today, Steve, to share your expertise. So welcome, and I will turn it over to you.
Well, thank you, Aaron. Yeah, so I'm in the groundwater section, or in a groundwater group, if you will, at the Water Survey. We're reorganizing, so there's some changes going on. But if you're not familiar with the Water Survey, hopefully you'll learn a little more about us again as well today. Um, so first thing I want to do is acknowledge some of the groundwater staff who provided most of the slides for today. Walt Kelly, who's was our section head, is retired. Dan Hadley's the current section head. Dan Abrams, Cecilia Cullen, Devin Mannix, Vlad Uradaki, Alan Jones, and Mike Krakowski. They're all working on projects related to the aquifers, or we're in the groundwater side, so it's going to be a heavy talk on the groundwater side. Um, but they're all working on projects in different parts of the state or through IDNR funds water supply planning efforts in Illinois, which some of you may be familiar with. Like the Mahomet Aquifer Consortium is a group that IDNR funds to look at possible management strategies for the Mahomet Aquifer. There's a group up in the Green River Lowlands. I think there's 8 priority regions that make up the state, and we've worked in several of those. And Jason Zhang from our watershed science group is in charge of most of the surface water side of things, where in areas like down by Wren Lake, where there is not a lot of high quality groundwater. So the Wren Lake supplies water to about 13 counties and all the communities there. So yeah, if you have any questions, I can certainly get some of these directed to wherever they go, but these folks really have put most of the information that I'm using today together. So a little bit about the water survey. We were under a number of state agencies until 2008, when we were brought into the U of I along with our sister surveys, the Geological Survey, Natural History Survey, Archaeological Survey. Now we're all under the umbrella of the Prairie Research Institute, which is under the OVCR's office at the U of I. But we started in 1895, so we're 130 years old today, or this year. And here we deal with anything related to water, chemistry, atmospheric sciences. We have a group that does FEMA work. They revise floodplain maps and do hydraulic modeling of flood instance in Illinois. We house a state climatologist and the state hydrologist. And I'm in charge of this name is changing, but I meant to change that. Environmental Public Health Information and Data Services section. We started 3 years ago because we've started looking more at issues related to public health in the efforts we have. We have a number of outreach and education efforts through our private well class program and our wateroperator.org program. And we also have a third one on decentralized wastewater on-site systems. And so public health ends up being a big part of that, or environmental public health. And so we started a group that are really focusing on some of those issues, which I am not talking about today. So just some examples. We have a really rich history, and being here, I've been here a long time and very fortunate to have had a chance. We discovered 1,500 glass plate slides that date back to 1900, and they have pictures like this: a young man helping one of our scientists in 1913 in New Athens, Illinois. In our files, we house the state's well logs, and so there's records for every community in the state going back to whenever they started serving water or developed a wastewater system. Pana, Illinois is a good example. They built a water plant in 1913. They weren't using it because the mayor thought it was too expensive. They also, only half the town was sewered. The other half was still septic and direct runoff. And so they had a typhoid outbreak. The water survey investigated. There's 50, 75 pages of information based on that investigation. But in the end, they discovered it was a Pana ice cream company. Everyone got their milk from one large tank or vat and used a bucket to scoop it out, and it got contaminated. And so 32 residents got typhoid between April and May of 1916. And you can read this whole story. It's really It's actually an interesting story just because the ice cream company denied that it could be them. And think about how that would happen today with lawyers and everything else. It's pretty interesting. So today, the Water Survey really does a lot of public service, research, and data collection. And we're really known for those things as far as we house the state's well logs. We have a monitoring well network around the state. I've installed probably 60 or so monitoring wells myself. And we also have a lab that collects samples to support our research projects, and until 2008, offered free water testing to any homeowner in Illinois with a well. That's gone away, unfortunately, but because of that, we have a lot of good water quality data for the groundwater in the state of Illinois, historical information. On the research side, I mentioned water supply planning, which is a statewide effort funded by the Department of Natural Resources. We do one-off studies for other groups. Number of counties have had us look at their water resources, especially in the Chicago area, which I'll talk about some of those things today, where there's a competition for resources, believe it or not, where most of the state has plenty of water. There are some areas that do not, either because of just not having source water, or the source water may have uh, issues like salty water in southern Illinois. So as far as water sources in Illinois, obviously Chicago and the whole Chicago metro area gets a lot of its water from Lake Michigan, which is this picture of this crib here is an intake near Chicago. And the groundwater for the Chicago area is all supplied by the St. Peter Sandstone. So it's Starved Rock, LaSalle, Illinois area. That sandstone is at the surface, but it's an inclined geologic bedrock layer. And so under the Chicago area, it's as deep as 1,600 feet below land surface. So there's a lot of deep wells in that area, and that shows the variety and difference of the bedrock in Illinois. We're also glaciated. And so on the surface water side, Lake Michigan provides a lot of water. Up to 3,200 CFS is what we're allowed to take out of Lake Michigan because of the Supreme Court decree in 1982, I think. We also have a number of communities that use rivers and streams, or lakes, Decatur, Springfield, a few others. And then we also have pretty abundant groundwater resources. About 2/3 of the state is glaciated with potable water. And so when the glaciers came and melted, they left large deposits of sand and gravel. We also have shallow bedrock in areas like in Kankakee County that are used heavily for irrigation and for water use. The deep sandstone I mentioned is the St. Peter sandstone and other bedrock aquifers that are fairly deep. It's only usable in the upper third of the state because further south it becomes salty. It's remnants of a sea from millions of years ago. The water down in southern Illinois in that same aquifer has a TDS or chlorides in the as much as 10,000, which is basically seawater. And so it had to be treated pretty heavily in order to use for drinking water supply. But we also have mixed sources, whereas someone's using both groundwater and surface water or trying to supplement one with the other. A good example of that is Aurora, Illinois. It's on the Fox River. It's interesting because they have both groundwater wells and they have intakes on the Fox. So at any given time, between 30 and 70% comes from those three. Well, they have three different aquifers they can use. They have shallow dolomite as well as the deep sandstone, and they even and the Fox River. And so it's really variable depending on their needs and the level and the chemistry, how they decide to do that. But on the other side of the fence, after the water's gone through, all the water comes back to their wastewater plant. It's 100% discharge into the Fox. So Aurora actually provides a net gain to surface water because of the discharge of their wastewater system for water that's been used already. So it's very complicated. For some communities, and so we have on our website this Illinois Municipal Water Use Map. Dan Hadley developed this probably 5 or 6 years ago, but you can look at where everyone gets water, every community in the state. Every public water supply has to provide information to the Illinois EPA. They also have to meet the standards of the Safe Drinking Water Act. So they're testing their water every 3 months. They're treating for any contaminants they might have. Um, and so there's just some interesting things that have worked out because of some areas that have more water than others, or some communities that were too small to maybe get into the water business. And so the Chicago area, I'll show that in a little more detail in a minute. But a couple examples. The one on the left is the Clayton Camp Point Water District, small little town, but they sell water to a whole lot of folks. And then Champaign-Urbana, we're under Illinois American Water, and their contract with the cities here is 100 years long. And I know they re-upped it around 15 or 20 years ago, but it allows them to sell water within 50 miles of Champaign-Urbana, which, someday that could be an issue if they actually expand that much. Currently, there's a number of communities, our small bedroom communities around Champaign-Urbana that do use or do have their water source as Illinois American. And so for the Clayton Camp Point, they have a water supply that's in a sand and gravel aquifer, I believe. And the two towns run it, but they provide water to a lot of other folks in this area. It's interesting, near Quincy, which is where we're at, we're just west of Quincy or just east of Quincy here. There's a shallow bedrock aquifer that's also salty, but you can find fresh water underneath it. And so it's just the way bedrock is laid, and all that material is on the earth. It's not flat, it's at an angle. And then you have places where there's breaks, anticlines and synclines, which I'm not a geologist, so that's all I'll say about that. But because of that, some places have water and some don't. A really interesting issue again with Illinois American is that they sell water to the Embra Water District, which it says Mahomet here, it means Mahomet aquifer groundwater, which are the wells for Champaign-Urbana are west of Champaign in the Mahomet aquifer. It's a glacial sand and gravel aquifer that sits, it's an old bedrock river valley. Think of the Grand Canyon, it's a bedrock river valley, except a glacier came along and filled it with sand. And so we have as much as 200 feet of sand in some areas. And so that's an abundant water supply, just because the porosity of sand and gravel can be as much as 30%. So if you have 200 feet of sand and it's full of water and then it spaces between the sands, you took all the sand away, you'd still have 60 feet of water. And so that is a lot of water over. The aquifer stretches from near the state line on the east to the Illinois River on the west. So it goes over 100 plus miles, and it's as much as 12 or 15 miles wide. So that's a lot of water. And so they sell water then to the Umbra Area Water District, who sells that. Then they sell to the Clearwater Service Corporation, which then sells to the Lake Mattoon Public Water District, which uses Lake Mattoon to some degree, but it bypasses both of those reservoirs then whenever they're doing that. And that's, dependent on weather and amount of water available in the rivers or in the lakes. We see the same issue with Bloomington Normal. Bloomington's using Lake Evergreen and Lake Bloomington. Normal uses wells. Bloomington's looking to blend just because of nitrate issues with their lake supply. So there's a lot of reasons why some of those supplies might be mixed, either because the sediment eventually fills up some of the reservoirs, and it's an expensive process. I know Decatur went through that about 10 or 15 years ago, where they dredged the lake and increased the capacity quite a bit. But it's also then surface water has issues because we're an agricultural state with nitrate and some of those things as well. Wren Lake, I mentioned that earlier as well. So there's really not a great large water supply in Southern Illinois, groundwater supply. And because of that, Wren Lake sells water to 40 different municipalities and other public distributors. So sometimes the water is basically passing through to more than one town. A long time ago, when these towns were smaller and water quality wasn't, I guess, as much of a concern, I'm not sure there, they had their own water supplies, or they found a way, or they they maybe had an alluvial well, which is along a river bottom. So the sands along the river are called alluvial. It's deposited by a river. So, and I'll show you, the American bottoms are a good example of that. but now they're all on Rend Lake, and so they're all supplied by surface water. And in this same area, I'll show you in a little bit, because there's not a lot of groundwater for a private system, there's a lot of large diameter or hand dug or bored wells in the southern Illinois as well. So the story here is Illinois, before glaciation a million years ago, had three sets of glaciers come through: the pre-Illinoian, the Illinoian, and the Wisconsin. And each one advanced, 1,000 feet of ice, full of grinding up sand and rock and dirt and everything else. And then as they melted and receded, channels formed, and a lot of these bedrock valleys that were the river valleys prior to glaciation filled up with sand and gravel. And so each one of those advanced and receded. We know the geologists tell me there's, three. These are the times. The pre-Illinoian down here in the bottom, it says 1.6 and older to 190,000 years ago. And the other two are much more recent. The Wisconsin glaciation is the latest. And so that's our current land surface. And if you've ever driven I grew up near Lincoln, Illinois, which is just north of Springfield. If you've ever driven from Peoria or Morton down I-155 to Lincoln, when you get just about to Emden, Illinois, you drop off about 80 to 100 feet. Well, that's the glacial moraine called the Bloomington Moraine, I believe, where the last glacier stopped. And so it melted, all the debris fell out and formed the land surface there. And that's why it's 80 feet higher, 100 feet higher than everything further south and west of it. And so there's an area called the Driftless area. I was just up there near Madison, Wisconsin. So the glaciers just miss this wide swath of Wisconsin and a little bit of Illinois, Joe Daviess County. And so there's, it's bedrock at the surface because there's no glaciers that, when they melted, covered all that up in sand, gravel, silt, clay, and all those sorts of things. So in Champaign County, for instance, it's about 400 feet to bedrock, whereas in far southern Illinois, bedrock's at the surface, and as well as in Joe Daviess County. So this is what we have for groundwater in Illinois. On the left is the deep bedrock aquifer. And if you notice, that line is really smooth where the aquifer starts and stops. That has nothing to do with whether there's bedrock there. That deep bedrock exists over the entire state. That's an arbitrary line. That is where the TDS, total dissolved solids, because it's becoming salty. I'm not sure what the value that was used for that. It might be 500 or a little higher. It might be 1,500 parts per million. But you can start to taste water being salty at around 500, I believe. And so, but it's treatable. But once it gets further south, and I mentioned, 10,000 TDS, that's saltwater, seawater, and it's really expensive to treat in order to provide, especially for like a community water supply. And it's not anything you can put on a crop just because it's so salty. So the issue, though, is because of all the pumpage in northern Illinois, this line is moving up slowly. Who's to say how long? Some of the pumpage in the deep bedrock aquifers going away, which I'll talk about in a minute, but this line is moving north. And recently Bloomington, trying to combat the nitrate problems they have in their lake water, decided to drill a well into the deep sandstone, knowing they're right on the margin where it might be too salty and might not be. And I don't even know the results of that. I know they just did that a few years ago. How much they're using that well to blend, but it's there's plenty of water down there. It's just you're going to have to treat it, is the bottom line. But it's the deep sandstone that's being used in the Chicago area. So we also have shallow bedrock. A good example, Kankakee County. All the irrigation in that area is in the shallow bedrock. There is a sand on top of the gravel or on top of the rock, but it's fractures in the bedrock where most of the pumpage is coming from. And that's dolomitic limestone or dolomite, most of it. And so it's a good water source in these areas. It has enough water to supply to a well, and that's why it's mapped the way it is. And then if you look at the map on the right, the sand and gravels, Those areas like the Mahomet that runs from Vermilion County and the state line over to the Illinois River in Mason County and down then through, that was a bedrock valley dug into the rock by a river, by water running through it over millions of years. And then when the glaciers came along, when they melted, just like any other river system, you have sandbars, you have where the water's running faster, you only have boulders or larger rocks. And where the water slows down, then you have finer sands and gravels, and eventually you have silts and clays. And so we see layers where there's been three glaciations, there's three aquifers. There's the coarsest materials at the bottom, then the finer sands, then clay and silt. Then another glacier came along and did the same thing. So you have these layers of gravel, sand, clay and silt, gravel, sand, clay and silt as you go up to the surface. But the Mahomet and the Sandcody, which is the area in the Green River Lowlands up by the Quad Cities, are two of the largest sources of sand and gravel aquifers in the state. And if you notice, the rest kind of follow river bottoms, right? The alluvial sands I mentioned, like along the Illinois, if you get down closer to the Mississippi River. And along the Mississippi, those thin areas, those are the bottom ground around the Mississippi. Like if you're driving down to St. Louis and you go down the moraine at Collinsville, that's all that sandy soil. I know they grow a lot of horseradish down there and some other things. That's all because at one point that was part of the melting glaciers. That's why the Mississippi was that wide. It was 12 or 14 miles wide when the glaciers were melting. And so that's all full of sand, and that's what creates quite a water supply. So that's kind of where we're at in Illinois as far as what we have. You notice Southern Illinois really is deficient of any major aquifers, and that's why Wren Lake is where it's at and the purpose it serves. So I'm going to talk about the Chicago region first, the St. Pete Sandstone. So in 1964, William Walton, who was a pioneer in hydrology who worked here, estimated the yield of the aquifer, this deep sandstone that could be pulled without mining the aquifer in perpetuity, was 65 million gallons a day. Well, if you follow the big graph and you look at around that time, 1965 or so, is when we hit 65 MGD. As Chicago and the Chicago Metroplex area grew, we see pumpage got as high as 180 million gallons a day. So what that did, if you look at the map on the right, is it caused these cones of depression. Those are water level maps of elevation. You can see Milwaukee pumps from the deep sandstone, and then Chicago and Elmhurst and a lot of communities. Joliet is now the big pumper, but that's mean sea level elevation, I believe, which is, the water level was around 700 feet mean sea level. Pre-development is what's been modeled and estimated. And you can see here out to the west, there's a 750 contour that's probably, and there's an 800 contour. So if there were no pumpage from the St. Peter Sandstone, it would be at those elevations. That's just the natural system, but we've caused these huge cones of depression. This is in 73, which, was, there was still a lot of pumpage because the whole Lake Michigan allocation was really coming online. Towns were added, still being added today. So that's a lot of drawdown. You think about 800 to 1,000 feet. And so that's the problem. Mining that aquifer, there's millions of people who would be without water if it actually they actually caused that cone to sustain itself. So where we're at today is the figure on the upper right shows the drawdown or the head, which is the mean sea level elevation, where the really dark areas that are greater than 700 are kind of the natural system. Right now, Joliet is the largest pumper, and so that's why the cone of depression is centered there. Most of Chicago is off of the aquifer or the Chicago area. And so what we see from 1980 to 2014 is the figure on the bottom right. There's been recovery of as much as 300 feet or greater than 250 feet in the Chicago area of water levels in the aquifer from what they were in 1980, just because of that not being used anymore. So it's a time-consuming thing. That line, that black line that's in there is a sandwich fault. And so it's where there's a break in the geology. So one side shifted and the other didn't. So it's not a continuous set of geology anymore. Like if you have a limestone and a dolomite and a shale, someone just came in and sliced through that basically and lifted one side up or dropped one side down. So they're not connected anymore. And so it causes a lot of water flow issues around that. And that happens to be where Joliet is. But so you can see from this how much drawdown there's been because of the pumpage in the Chicago area. That 3,200 CFS, that is, oh, I'm going to go back. I forgot something. The small graph in here is some of the pumpage up through about 2012 or 2013. And so if you remember, 65 MGD is what the aquifer can sustain, and we're up in close to 100 MGD again. And so just because of growth and industry, especially in the Joliet area, they're all on groundwater still. No one's on Lake Michigan allocation. And so we still see a significant drawdown. So what's going on is that Joliet's decided to go onto Lake Michigan. It's a $1.2 billion project. And there's a lot of other towns in the area that are also, as well as the manufacturers in that area along the Des Plaines. And the issue here is we tried to tell Joliet, 25 years ago that we modeled what was going to happen in the drawdown and said, you're going to run out of water. Well, it was a matter of who was in charge. And once the water system folks who were there retired and some new folks came on board, we presented what's going to happen. If they don't get off the aquifer by 2030, they're likely to have supply interruption from the deep sandstone. So now there's a effort. They've already got permission from DNR to supply water from Lake Michigan. I believe they're putting a direct line that they formed a water district with all these communities, and they're going to be a provider. You can see if you look at this distribution on the map, where there's the Chicago plant, there's 2 or 3 Chicago plants, and then several others from communities north of that, where they're distributing water to, I don't remember the current number, but there are a lot of communities in the Chicago area that are all now on Lake Michigan water. A few still have an emergency well in case there's some kind of issue, but and they have to monitor that and measure the water quality, and they have to pump it regularly just to waste. But it's quite a network, and it's all managed by DNR because in 1980, all the other Great Lakes states in Canada sued Illinois for taking water out of Lake Michigan, fearing that it would reduce water levels in the lake. And so the Supreme Court capped it at 3,200 CFS, which is about 2 billion gallons a day. And it's not enough water. Yeah, so I see there's a note here. Where's the watershed boundary? Well, the Lake Michigan watershed is within miles of the shore. Everything else is the Illinois. I'm not a surface water hydrologist, but you can look that up. We are moving water from one watershed to the other, which is where part of the issue came in, because a lot of that's discharging into the Illinois River water system instead of staying in the Lake Michigan watershed. So those major bedrock valleys I mentioned, you can see here that's also where the aquifers are. So the Mississippi, Illinois bedrock valley and is now the Green River Lowlands area. Lee, Whiteside, Henry, Bureau, and then the Mahomet aquifer runs from Vermilion County, Ford, Champaign, all the way to Mason, Tazewell, Cass. And you can see the thickest parts. The amount of glacial sediment is deepest in where those rivers were cut through the bedrock. And that's now those are full of sand. So there's certainly not a lot of sand available in those areas. You also see a lot of irrigation where it's close to a river, just because it's all sandy soils. And so, but they are major water sources. Even Springfield, which is in Sangamon County, had entertained the idea of, basically running 40 miles of pipe up to Cass or Mason County to put in a well field to supply, help supply the city of Springfield as it's grown. And they came up with three options. I think Lake Two was the final solution. I have no idea where that's at today as far as legally or whatever. Um, yeah, but not all sand and gravel aquifers are located in bedrock valleys. So you can see where it says this glacial sediment thickness, that doesn't necessarily mean sand, but it does mean that it's from the glaciers. So there's likely some sand in it. They follow the river valleys, and many of the current river valleys are close to, if not over top of, the buried river valleys that became aquifers full of sand. Yeah. So the Mahomet, it's something that I've worked in most of my career. We're in Champaign County. You can see how the arrows point towards Champaign. That's because the pumpage here, which is around 23 million gallons a day now, is causing a cone of depression. So water is actually flowing naturally. The water in the Paxton area, and you can see where the highest levels are just on northern Champaign and eastern Ford County. Those are the highest water levels based on those potentiometric surface water lines. And so that's the highest area. There's a lot of recharge and it's pushing water through the system. It's part of the hydrologic cycle. Water runs into the aquifer. Some of it discharges within days. Some of it stays in the ground for years or millennia. But it eventually discharges. And then it goes to a river, the ocean, rains, and evaporates and rains and starts over again. And so, but we've changed the flow here, and there's a divide near Allerton Park and along the Sangamon River, west of Champaign near Monticello. And that's because of the pumpage from Illinois American for Champaign-Urbana water supply has reversed the flow. There's enough drawdown that water is actually flowing back to the east along there. And we also know there's a connection with the Sangamon River and the Mahomet Aquifer, just because of complicated geology in that same area. And whenever it's a wet time, we see water flowing both directions. Sometimes, like during the drought in '88, the Sangamon River went dry in that area, and it's because Decatur was pumping supplemental water for Lake Decatur from in that area, and that drained the river basically. And so it's really complicated, the geology, because it's glacial geology. There's tunnels that formed in the glaciers, all these things that I don't really know a lot about that caused all these complications with where sands are interconnected or not. But generally, the flow is from east to west. And once you get over towards Mason County, where it's much more sandy, you see this, it's all running to the Illinois River, either through the Sangamon or the Mackinac, or directly to the Illinois. And so the water levels in Champaign County are as much as 700 feet mean sea level, where at the river it's 420. So there's 300 feet of head difference, and that's what pushes water. Water wants to flow downhill, right? If I poured water on a table and lifted one end up, it's going to run down the table. And that's the same thing here. It's pressure. It's trying to find the lowest pressure. And so it's a natural system that discharges. And those little white areas, like over by Lincoln on the edge of Logan County and up by Tremont and that area, that's where the glacier did not leave any deposits, at least any sand deposits. And so we found one of these near Hopedale trying to drill and wondered why there were no wells. We had no private wells within almost 10 square miles. And it turns out it's because there's a bedrock high there. So there's a little pillar of bedrock that didn't get, worn away by either the running water from before glaciation or the glacier didn't break it or whatever. And so there's just no water there. It's just bad luck if you're out in the middle of that area of Tazewell County. So the other thing about Mason, or about the Mahomet, is water use. By far the biggest use is irrigation. In 2012, during the drought, we estimate that in Mason County and southwestern Tazewell County, where you see all the black dots, those are center pivot irrigation. We estimate they pumped nearly 2 billion gallons a day on some days. And so that rivals all the pumpage for the Chicago area, um, which is amazing. But because it's sandy there, they also get a lot more recharge. So in Champaign County, the Mahomet Aquifer is buried underneath a lot of glacial till, sands, or clays, tills, things that don't let water down through and infiltrate into the aquifer. Where in Mason County, it's sandy at the surface. So in Champaign County, we get a 1/4 inch of recharge a year into the Mahomet Aquifer, which doesn't start till about 160 feet below land surface. Where in Mason County, they get 7 to 12 inches of recharge a year. So how that plays out then is, well, so one, this is from 1930 to 2005. This is the drawdown currently in the aquifer. And we know this from long-term observation wells. So we have wells that have been in place for, nearly this entire time. There's no difference in water level in Mason County from before irrigation even started because there's so much recharge to replace it. Where it's buried in Champaign County, and because of all the pumpage with Only American, um, we're creating 60 to 80 feet of drawdown. And if Illinois American, or I use the company, but if our public water supply stopped using groundwater completely, over time, this would all recover. That's the thing. So it is complicated. And the schematic on the left shows you, I mentioned that there's some interesting connections. So the leaking stream would be the Sangamon River near Monticello. And you've got all this weird places where all the sand that was deposited by different glaciations receding and advancing left this basically a sand tunnel through right to the Mahomet Aquifer. In the end, it's all pushing towards the Illinois River. And the high recharge area there would be Mason County or the sandy areas, and also Western or in Tazewell and like Logan, which that's where I grew up. So I know the area well. Over 1 billion gallons a day. It's actually higher than that during drought years. This is in 2012. We mapped all the pivots here. There's about 2,300 center pivots between, and this isn't just Mason County. It includes a little bit of Tazewell, but it's the area that was outlined for the Imperial Valley Water Authority. We have a Water Authorities Act in Illinois that allows local areas to form their own water authority that give them some local jurisdiction over high capacity water use. And so Mason County and 6 townships in Tazewell County formed the Imperial Valley Water Authority in the late 80s, I think, maybe early 90s. We actually work with them. We have monitoring wells and rain gauges over here, and we have a lot of information on how the pivots affect pumpage and drawdown and water levels every year. Water quality issues in the Mahomet in that area. And the boundary is a estimated boundary. We don't know exactly where the sand stops and starts throughout the whole aquifer. The only way to know where there's information is through well logs, and they don't exist at that kind of scale. But what we do know is that we find a lot of arsenic in the Mahomet Aquifer and in the Glassford, which is the shallow aquifer above it. So especially southern Champaign County in the Tolono area, there's a thin Glassford aquifer that's used a lot for water supply for private wells. And they're not on the Mahomet. There is no Mahomet there, which is the deeper aquifer. But we see arsenic as much as 150 or 200 parts per billion, which the standard for a public water supply is 10 or less. So if there's a public water supply like McLean, Illinois, I know their raw water is about 48 parts per billion. They have to treat to get it under 10 before they can serve it to their customers. The arsenic's naturally occurring. Arsenopyrite is a common element, if you will, in the sand and gravel makeup of the Mahomet, both in the Mahomet sands, which came from the west, from the Mahomet Tays River, and the sands that were deposited there, also from the Sankote from the north. And so the Mason, Tazewell, Logan County area is called the confluence. It's where 2 major bedrock rivers met, the Sankote River and the Mahomet Tays, which went all the way to West Virginia. Now, the sand and gravel that filled those up doesn't go all the way back to West Virginia. There's places where it's cut off and it's all fines and there is no aquifer, but it definitely goes into Indiana. And yeah, it's naturally there. We've done a lot of arsenic sampling myself. There's no rhyme or reason. It's based on what's available chemically and bacteriologically in the near the well. We see wells within literally 30, 40 feet of each other that may be an order of magnitude different in arsenic value. And so it's really what I tell private well owners is you just need to test, especially if you're in the Mahomet or Glassford. It's just naturally there. You may have no issue. It doesn't vary with depth that we can figure out. We've done a lot of testing to look at those things. And then nitrate, and again, these samples are not necessarily in the Mahomet aquifer. But what you do see, and what this shows, everything on the southeast part of this in Champaign and Vermilion County is shallower aquifers, or maybe even dug and bored wells. Where most of the Mahomet itself, there's much lower, the dots are much smaller. We find like in DeWitt County and Piatt County, it's one of the areas of the state where nitrate's still at background levels, where most of Illinois is not anymore. But when you get over to Mason County, where sand at the surface, there's a real issue with ag chemicals because it's infiltrating directly in the ground, which is one of the other problems with Mason County. Oh, and I have talked a long time. Is that there's a lot of sand points because it's cheap to do. So people go buy their sand point, they pound it in the ground themselves you get it from Farm and Fleet, and they use that for their water supply. Very likely that water is contaminated. And so it's really a bad idea to have a well that doesn't meet construction code and isn't protecting your public health. I'm going to go quickly through the Green River Lowlands, the other area here. So it's up in Sterling, Dixon, Bureau, Lee Whiteside County, in that area. It's also a glacial valley. And so, but that darker area is where there's a moraine. And one of the things I want to point out is in most of these areas, we have monitoring wells like the ones that are listed here, the WTS, and that's all on our website. And you can actually see what the value was for the water level an hour ago. These screenshots are a little old, but it goes all the way to today, and you can zoom scale for dates and all that sort of stuff. And it's all on telemetry. We can see it an hour from when it's delivered. And lastly, I want to talk about the American Bottoms, which is the St. Louis area on the Illinois side. And this is a schematic on the bottom of a cross section till you get to the bluffs, right? Going east. And so this cross section is the width of the original Mississippi when the glaciers were melting, which, I mentioned going all the way back to Collinsville. We're talking 10, 12 miles. And then there's bluffs on the Missouri side as well. And so a lot of sand deposited here. There's also a lot of industry. We have folks who are working in this area just on all the movement of contaminants from some of the industrial facilities in the area. There is some alluvium, there are some silts and clays, but it's mostly sand. So I do want to mention this is about shallow bedrock aquifers, but because there's no shallow sands available in the southern 2/3 of the state, this is a map of drilled versus dug or bored wells for the state of Illinois, the one on the right. And all of those red dots are hand dug or bored large diameter wells, which you can see the diagram on the bottom left. I grew up on one. My grandpa hand dug our well in 1933. It's brick lined. It's only 14 feet deep. That's what people did. But nowadays, if you have an aquifer, you're putting in a drilled well, either bedrock or sand and gravel. These are all the bedrock wells in the lighter color. But there's a lot of bored wells because that's the only water supply you have. And the reason you drill it, the reason you have such a 3-footer larger diameter is so that it can store water. There's still water in the till and the clay, but it seeps slowly. It doesn't move through the system very quickly. And so the idea is there's a natural water table. That's where the water is going to fill up in the well. You use it in the morning, you go away for the day. It can refill while you're gone. I know if I left a hose in our horse tank and forgot about it, we had times in the summer we were without water for 2 or 3 days. I'm going to quickly go through some of these things. Arsenic, radium, barium, and I mentioned TDS already. There are really the issues as far as natural, and then road salt and nitrate are kind of our big problems with man-made. So these are just some of the communities in Illinois: Shelbyville, Mount Pulaski, And you can see how everyone's nitrate values have gone up. The standard is 10. And so some of them had to start treating to remove nitrate because now they're over the standard. Um, Another really vulnerable area of Illinois are where we have karst aquifers. If you've ever been like in Pike County and seen these sinkholes, 80% of the wells in that area are positive for coliform or E. coli or both. There's a lot of livestock. People throw things in those sinkholes. It's just anything from the surface can get down in that system, and it doesn't break down as well once it's there because it's rock. And it's basically karst is very friable rock with water solution cavities throughout. There are caves, all those areas. So, I mean, there's a lot of areas that are karst throughout the United States, and they're a problem because of this. There's a lot of it just has to find one spot to get down into the aquifer, and it's there. I won't go through more of this, but if you want more information, Walt Kelly did this work. The first place they've ever found microplastics in groundwater was in karst in Illinois. And that was Walt Kelly from the Water Survey and Sam Pano from the Geological Survey. They sampled some springs and caves, and that's what they found. Chicago area puts on 270,000 tons of road salt. Yeah, 55,000 lane miles. And so you can see the shallow sands and gravels up there. Many of them aren't usable or they're getting much worse. These are all communities in Northeast Illinois. We see the rivers up there. Some of them have very high chloride values. And so anyone who's using a shallow well, any of the communities up there that are still on shallow groundwater, which a few are, they're seeing real problems because of that. And then arsenic, a lot of the sampling we've done is in the sand and gravels just because that's where we find most of the arsenic in Illinois. Yeah, and there's a lot there. And that's what I have. So I'm glad to take a look here or answer any questions you might have. I think I need to stop sharing, right?
Sure. Thanks, Steve, so much for sharing all that wonderful information with us. And I think you have answered nearly all of the questions. There's one in here. But as we're answering that one, I invite anyone else. We have about 10 minutes. So if you have additional questions, feel free to add those into the chat. There was one that Carmen put in here, if you can speak to about how the newly built basins by the MWRD will affect Lake Michigan.
I don't know for sure. I've actually been down in the deep tunnels, and it's really about stormwater discharge. I assume that's what you're talking about. The one where I-80 runs over both sides of that large quarry. And that's, by law, they have to effectively keep stormwater and the other part of their wastewater separate. And most large communities, I mean, very large cities like Philadelphia, New York, Chicago, they're so old and their infrastructure is so old that that's a really hard nut to crack. And so all of that's an attempt to try to not overburden their wastewater facilities. There's a slide I took out that showed in the early 30s, everywhere where we still were putting sewage directly in our rivers. And there was a bullet based on size and population. And there's all these little bullets around there's about 120 communities that were still putting sewage directly in the rivers. And then there's this giant bullet around the Chicago area where, still several million people and they're still putting a lot of their sewage into the rivers just because of the capacity that provides. So I know that's the point of those as far as how it affects Lake Michigan. Lake Michigan has been as high as it's ever been in the last few years. And so, it's a drop in the bucket. There's places where the Lake Michigan's over 600 feet deep. It's just a huge reservoir. And so I think all the concerns about some of those things, not having enough water or taking too much water out of Lake Michigan are totally aren't a concern in the end.
Okay. We had a question Do we need to worry about the growing presence of data centers and their extensive water use?
I think that really depends on where they're at. You
Mhm.
know, we did a bunch of work for Bloomington Normal in the 90s to look at the Mahomet Aquifer as an they were considering putting in a regional water supply out west of Bloomington Normal that would not only supply Bloomington Normal, but about 20 communities in the Tazewell and McLean and Woodford County area. Um, and what we learned is that um, there's probably 200 million gallons a day of water available. And that once you get further west in the aquifer, because it's closer to the surface. And we actually were contacted by a company who wanted to build a semiconductor plant near Hopedale. And we did some modeling to look at what their 2 or 3 million gallons a day would cause. It's a real blip. Even when the all the ethanol plants were being considered, one was proposed near Emden, Illinois, and so we did a little project for them to estimate the drawdown around this 2 million gallon a day of pumping groundwater. And we saw less than a foot of drawdown at 200 yards. I mean, there's just so much water available in some places. But we also saw ethanol plants that were proposed. And there's one, I think, up by Gibson City, maybe, where they didn't do their homework and there was no water supply. And so in those cases, I think that plant actually has a 15-mile pipeline to reach an aquifer. And if you think about the cost of running a 2 MGD line 15 miles, that's poor planning. And so it really comes down to that. And we get asked sometimes, not others, but we can certainly provide that kind of information. Obviously, development's great. You should use the water that's there. It's going down the Mississippi anyway. The more we use is a good thing, as long as it's not burdening somebody else. So
Okay, thank you. Um, do you have any thoughts on water reuse proposals as related to the Joliet industrial needs?
I do not. I don't know. Sometimes industrial water needs are much more strict than even potable water, depending on what kind of processes they're using. So many industrial facilities, the reason they have wastewater facilities is because they're treating so much of their water to get it even cleaner, for whatever process it might be. And so, water reuse is an interesting topic where we see a lot of it, further west. I know there's communities along the Texas-Oklahoma border that have been approved now. Los Angeles puts about 120 million gallons a day into these basically sand pits that recharge eventually their aquifer. And that serves two purposes. It replenishes their water supply and it keeps salt water from intruding more on their aquifer as they pump. So we don't have those some kinds of issues. We do have a gentleman here, his name is Devin Mannix, who's looking at water reuse or possible aquifer storage issues, and he's probably the person I would want to ask about that.
Okay. We have a well question.
Mhm.
Someone has a 20-foot shallow well and needs to fill it and wonders what material you'd recommend filling that well with.
So if you'll contact me, I can send you, we did a demonstration of filling a shallow well for a bunch of health departments in Western Illinois that someone contacted us about an old dug well that was 4 blocks from downtown in Macomb. The community has had public water since 1916, and someone bought this home and found that there was an old well in their backyard. So we did it as a demonstration, working with the county health department there and the groundwater guardians group at Western Illinois University. There is a well sealing code. The IDPH has a well sealing code. If you Google that, your best bet's probably to hire a well driller or a well contractor to come out and fill it. It's gravel and bentonite. Bentonite pellets are the best thing to use. Um, but yeah, there's actually a law that requires you to do it a certain way, and so I'd go that direction if you're going to do it yourself. And depending on the county, some county health departments will want to be out there on site. If you do that, others will just want you to let them know that you filled it if there's a log for it.
Awesome. Another question, do you anticipate the PFAS problem increasing in Illinois aquifers?
I th- I uh, I think we're going to find that PFAS is a much more ubiquitous issue than we know even today. I think in 20 years we're still going to be dealing with PFAS issues. Um, and it's unfortunate. It's expensive to treat for, and expensive to test. Actually, there is treatment available for, especially for a home that may have issues with PFAS. And what we're learning from others who are doing research with private wells is that it's typically the only source available would be the wastewater from a septic system. And you think about, it's in our clothes, it's on our skin, it's in our bodies. Um, everything we do discharges. We're adding PFAS to the system, and there's so much of it out there. There's even proprietary PFAS chemicals that they're patented, so you don't even know what the formula is yet. And I learned that this summer at a public health meeting. So it's going to increase. There's a lot of people, there's only six regulated PFAS today. There's probably going to be, I would guess in 10 years, there's going to be three or four times or more that many that are regulated as there's so much research, although that may be slowing down soon. But there's so much research going on, looking at all those things, trying to come up with methods, not only for detection, but also for treatment, because there's so many different ones that do different things.
Mhm.
So it's really a problem. Um, and that's just the way it is. So someone
Well,
asked, what is a sand? Oh, I think I explained that, didn't I?
I
Yeah.
think so.
Yeah.
We will do one more as we finish up. Um, we've got one about Lamont, if you have specific answer to that one. Lamont Township is not joining nearby communities and moving to Lake Michigan water. Do you know what the capacity of the aquifer used by Lamont is, or would
I
this
have no idea
follow up?
offhand. There's other folks working on that. Dan
Mhm.
Abrams from our office is probably the person to contact. But that's part of the concern is that some communities are bowing out of joining, assuming that because all the other pumpers are off, then it'll be okay. But I mean, water levels are steadily going down. And if enough folks don't go off of Lake Michigan, it's never going to, or go off of the deep sandstone, it's not going to recover.
Mhm.
And that's the little I know about it. But Dan Abrams could explain all of that. He took all the heat, met with all the politicians and all the newspaper people, and he did all the modeling. He's a really talented groundwater modeler, and yeah, so
Awesome. Well, I know there have been a few other individual questions about specific counties or towns, so I would encourage you, if you wanted to follow up and reach out to Steve. If he can't answer, I'm sure he can direct you to the right person to help answer your question. But thank you so much, Steve. Really appreciate you sharing all of this wonderful information, and thank you everyone for being on today. I am gonna share. Our next Everyday Environment is in webinar is in May. And so I will share the registration link. We'll follow up with that in an email too. But in case you want to sign up for our next one, I put that in the chat box for everyone as well. So thank you, everyone. And thank you, Steve.
yeah, thanks for having me. All right, take care.
Bye, everyone.